Hello students, my name is Professor Muhammad Asim and we are doing ADMath. ADMath for IGCSE students which have syllabus code 0606 and for CIE O-level students which have syllabus code 4037. So both kind of students can get equal benefit from this course. Students, in last lecture we finished exercise 13.3 from chapter number 13 named vectors. Today we are going to start last exercise of chapter number 13, that is exercise 13.4. The topic of this exercise you can see on your screen, constant velocity problems. But students, before I start the concept of this exercise, I would suggest all those students who are new in my channel, kindly go to my playlist. There is a folder, name is ADMath. Watch previous lectures of this chapter. After watching previous lectures, definitely you have good command on this topic. So let's start the concept of constant velocity problem. You know the formula of speed is distance upon time, and the formula of velocity is displacement upon time. What's the difference? Speed is a scalar quantity and velocity is a vector quantity, or shortly you can say velocity represent in terms of I and j, where I, j are the unit vectors. Okay, so you have studied in physics as well, so I am not going in detail. Just know the speed is a scalar quantity and velocity is a vector quantity. So for speed we need distance and for velocity we need displacement. Now another topic of this exercise is splitting a velocity into its component. You know, in two dimensions there are two components of velocity, that is x and y component. X component represented by cos theta and y component represented by sin theta. And you can see the velocity of a particle traveling northeast at 4 root meter per second can be written in the form of ai plus bj. So when I do questions of exercise 13.4, you will understand fully. So without wasting the time, because you know very well, because you study in physics, I am directly starting exercise 13.4 question number 1. Let's have a look. Question number 1, part A. Part A. Displacement, I represent displacement is capital D. 21 I plus 4 j, and time I represent small t, 6 seconds. Question is find the velocity. So we just see velocity is always equals to displacement upon time. So displacement is given 21 I plus 54 j, it's a vector quantity, upon time is given 6. So 21 I 6 I plus 54 j upon 6. 3 7s are 21, 3 2s are 6, 6 9s are 54. So 7 upon 2i plus 9j. And because the displacement is given in meters and the time is given in seconds, so our answer would be 7 upon 2 is 3.5 I plus 9j meters per second, or ms minus 1. This is the answer of part A. What is part B? Velocity is given 5I minus 6j meters per second. Time given is 6 seconds. Find the displacement. So you just saw velocity is equals to distance upon time, then displacement upon time, then displacement is equals to velocity into time. Velocity is given 5I minus 6j. Time is given 6. Therefore 5I into 6 is 30I. 6j into 6 is 36j meters. This is the answer of part B. Now move to part C. What is part C? Velocity V is given minus 4I plus 4j kilometers per hour. Displacement D is given minus 50I plus 50j kilometer. Find the time. You know the formula of velocity is distance upon time. Then time is equals to displacement upon time. I use the word distance, so we must use displacement because we are talking about vector quantities. So time is equals to displacement upon velocity. Displacement is given minus 50I plus 50j upon velocity is given minus 4I plus 4j. If I take common 50 from the numerator, so it is minus I plus j, and if I take common 4 from the denominator, 50 from the numerator and 4 from the denominator, so it is minus I plus j. I cancel minus I plus j by minus I plus j, remaining is 50 upon 4. So 50 upon 4 is 25.2, it is 12.5 R. So the answer of part C, displacement and velocity is given, time is required, which is 12.5 R. So I hope you understand entire question number 1. Now move to question number 2. So you can see this topic is very, very easy. Let's see what is question number 2. A car travels from a point A with a position vector 60I minus 40j. So I can say that this is OA. Position means related to origin. So 60I minus 40j kilometer to a point B with position vector. So we can say OB, position vector, minus 50I plus 18j kilometer. The car travels with a constant velocity and takes 5 hours to complete. So time is given 5 hours to complete the journey. Find the velocity vector. Very easy. We know that the formula of velocity is displacement upon time. How to find the displacement? Just subtract OB minus OA, because in order to find the displacement vector we need the final vector. How to achieve final vectors? We just subtract final minus initial, so we'll get the total displacement. So OB is minus 50I plus 18J minus OA is minus 60 plus minus minus and plus minus minus plus 40J upon time is given 5. So velocity is equals to minus 50 minus 60 is minus 110 I, and 40 plus 18 is 58J upon 5. Simplified, minus 110 upon plus 58 upon 5J. So it is minus 22I plus 11.6 J kilometer per hour. This is velocity vector. I hope you completely understand. Now move to question number 3. So this question was very easy and very important as well according to point of view. Question number 3. A helicopter flies from a point P with position vector. So we can say this is position vector OP, 50I plus 100J kilometer to a point Q. The helicopter flies with a constant velocity of, so velocity vector is given 30 minus A minus 40J km HR minus 1, that is kilometer per hour, and takes 2.5 hours. So time is given 2.5 hours. To complete the journey, find the position vector of the point OQ. So what I told you, how to achieve velocity vector, just subtract from final vector, that is final vector is OQ, which we have to find, minus initial vector, which is OP, upon time. Velocity vector is given 30I minus 40J equals to OQ is required. OP is given, that is 50I minus plus minus 100J upon time is also given 2.5. So 2.5 must multiply 30I minus 40J. 2.5 into 30 is 75I. 2.5 into 40 is 100J, and this minus 50 must be shifted over here. It is 50I minus 100J must be shifted over here. It is so 75I plus 50I, which is equals to 125I. 100J cancel by minus 100J OQ. Hence the answer of question number 3, the position vector of the point Q is 125 I kilometer. You must write with its unit, that is kilometer. If the velocity is given kilometer per hour and the time is given in hours, then the position vector must be in kilometers. Now move to question number 4. Let's see what is required in question number 4. A car, part A. Question 4, part A. A car travels northeast with a speed of 18 root 2 km per hour. Find the velocity vector of the car. So it is very easy. Northeast. So if I draw the direction lines, so this right side mention east, this is north, this is west, and this is south. So northeast means the midway between the line north and east, like this. Okay, so northeast, because the total angle from east to north is 90 degree, therefore 45 degree. Now we have to find the velocity vector. The formula of velocity vector is xi plus yj. So we have to find x and y. How to find? Draw the line, draw the perpendicular. This is 90 degree, this horizontal line x, this is y, and this line is the resultant vector, that is the hypotenuse, which is given 18 root 2. So we know from the simple trigonometry of right angle triangle, sine 45 is equals to opposite upon hypotenuse, that is y upon 18 root 2. Sine 45 is 1 upon root 2 is equals to y upon 18 root 2. Root 2 cancel by root 2. The answer is y. 18 ones are 18. This is the position y. Now find cos 45. So cos 45 is equals to adjacent upon hypotenuse, that is x upon 18 root 2. Cos 45 is also 1 upon root 2. You can confirm from your calculator. Root 2 cancel by root 2. This implies that x is velocity vector v is equals to xi yj 18j kilometer per hour. So this is the answer of part A. So hope you understand how to find the velocity vector with the help of speed. Now move to part B. So I am rubbing this. What is part B? A boat sails on a bearing of 30 degree with a speed of 20 km per hour. Find the velocity vector of the boat. Draw the directions: east, north, west, south. The bearing means an angle from the north. Always measure clockwise. So we can say This is the bearing which is given 0, 3, 0, and this angle should be 60 degree because the total angle is 90. 90 minus 30 is 60. And again draw the perpendicular line. This is x, this is y. Find sine and cos. Sine 60 is equals to opposite upon hypotenuse. This time the speed is given 20, that is 20. Sine 60 is root 3 upon 2, y upon 20, 2 tens are 20, then y is equals this, this, this is position y. Similarly, cos 60 is equals to adjacent upon 1 upon 60 is 1 upon 60 is 1 upon 2, 2 tens are 20, 10 ones are 10. Hence velocity vector is xi, that is 10i plus yj 3 root 3j kilometer per hour. So hope you understand completely part B. Now move to a plane flies on a bearing of 240 degree with a speed of 100 meters per second. Find the velocity vector of the plane. Very easy. Again, draw the directions. This is east, this is west, this is north, this is south. So this angle, bearing means angle from north. So from north, this is 90, this is 180, it should be 240. Should be 240. And if this one is 240, then this must be 30 because the total angle, 270 degree. Now again, draw the perpendicular. This is 90, this is x, this is y. And now find sine 30 opposite upon hypotenuse. The speed given is 100. Sine 30 is 1 upon 2 y upon 100. 250 is a y is equals to 51 is 50 meters per second. But students, we must put minus sign over here because this y is down. So for below the origin, the y-axis is negative. So y is equals to minus 50 meters per second. Now find cos 30. Cos 30 is equals to x upon adjacent upon hypotenuse, x upon 100. Cos 30 is root 3 upon 2, x upon 100. 250 is then x is equals to 50 root 3. And this is also negative because we are going from origin to left hand side, and left side of the origin is negative x-axis. Hence velocity vector is xi, that is minus 50 root 3 I plus yj. Y is also minus, so negative 50 j meters per second. This is the answer of part C. Minus 50 root 3i minus 50j. So hope you understand this very important question. Here we learn how to find the velocity with the help of given speed. Now move to question number 5. particle starts from starts at point P with position vector minus 80I plus 60J meter relative to an origin. So it is given as OP. OP is given minus 80I plus 60J. The particle travels with a velocity, it is velocity vector 12I minus 60J meters per second. Part A. Find the speed of the particle. That is, speed means the magnitude of velocity. How to find the magnitude? Square of the coefficient of I plus square of the coefficient of J square root. So it is 400. You can use the calculator. So 20 meters per second is the answer of speed. So this is very easy. Now find the position vector of the particle after this part B. After 1 second. We have to find the position vector of the particle after 1 second. So if we know the formula of velocity is displacement upon time. So displacement is equals to velocity into time. So if we find if we multiply velocity by time or time by velocity, the time is given 1 and the velocity is given 12I minus 16J. This can be right 12 minus 16, sorry, plus 12. So it is 12 minus 16 because 12 ones are 12 minus 16 ones are 16. Now the final position vector is, the initial is minus 80I, which is right, minus 80 and 60 plus 12 minus 16, which is equals to minus 68 and 144, because minus 80 plus 12 is minus 68 and 60 minus 16 is 44. Hence the position vector is 68I minus 68I plus 44J meter. This is the answer of part 1, B1. Now B2. Find the position vector of the particle after 2 seconds. So we use again the initial vector minus 80, 60 plus this time we have to multiply 2 by the velocity. Minus 80, 60 plus 24 and minus 32. So minus 80 plus 24 is minus 56 I, and 60 minus 32 is plus 28 J meter. Third part, 3 seconds. This time we have to multiply by 3. Part 3. So again minus 80, 60 plus 3 multiplied by 12 minus 16 minus 80, 60, 12 3 is 36, 16 3 is 48 minus 80 plus 36 is minus 44, sorry, minus 44I. 60 minus 48 is 12, so plus 12J meter. And this is the answer of B1, B3, first second, second, and third second. Now part C, find the position vector of the particle t seconds after leaving P. It's very easy. Just we make the formula. Part C. So our initial vector is minus 80, 60. So first we use 1 into 12 minus 16, then we use 2 second 12 into minus 16, then we use 3. Therefore we have to use t multiplied by 12 minus 16. This is the answer, because this formula gives the position vector after P at any time, 1 second, 2 second, 3 second, and t second. So this is the answer of part C. So hope you understand. That is our today's class. We did first 5 questions with all parts of question number 13.4, exercise number 13.4. If you feel any difficulty in any question from question number 1 to 5, write in comment box. I will help you. What left? Question 6, 7, 8, 9, 10, 11. So 6 questions are left. I will try to do all 6 questions in next lecture. So kindly do practice more and more, and kindly request to you, must subscribe my channel, and whenever you subscribe, don't forget to press the bell icon button so that when I upload my videos you will get the notification. Kindly share my videos, my channel, as many as you can. Okay students, good luck for next lecture.